This is question 6 from Worksheet 10 from Learning Outcome 2 of the course notes for Math for Engineering 3. And in this question, we're asked to find the volume of a solid formed by rotating this curve y is equal to 4x minus x squared around the x-axis, and we're given two limits as well. The formula sheet tells us how to find the volume of revolution for a curve. It tells us it's going to be equal to pi times the integral between the limits we've been given of y squared dx. Since we've been given y, we'll find y squared to start us off. So y squared is equal to 4x minus x squared, all squared, which is equal to 16x squared minus 8x cubed plus x to the power 4. So this is the expression we're going to be integrating. Therefore, our volume of revolution will be equal to pi multiplied by the integral between 1 and 3 of this expression we found for y squared. And this is a polynomial, so it's relatively straightforward to integrate this. 16x squared becomes 16 over 3x cubed. 8x cubed becomes 8x to the 4 divided by 4, which is the same as 2x to the 4, because 8 divided by 4 is 2. And x to the 4 becomes x to the 5 divided by 5. And of course, the square brackets have the limit 3 and 1 from our integral. This means our answer is going to be given by pi multiplied by 16 over 3 times 3 cubed minus 2 times 3 to the 4 plus 3 to the 5 over 5. And from that bracket, we'll extract the expression with the lower limit, so we'll have 16 over 3 times 1 cubed minus 2 times 1 to the 4 plus 1 to the 5 over 5. Put a bracket there as well. Now, we can carry out these calculations in a calculator. You can choose to simplify these things further if you wish, but it's also simple enough to enter them into the calculator. So we're going to have pi multiplied by our first bracket is going to sum to 30.6, and our second bracket is going to sum to 3.533. The 3 is recurring after that. You can round it to a suitable number of decimal places or use the stored calculator value. When we enter this expression into our calculator, the answer we get is 85.032 to 3 decimal places. And remember, this is a volume we're calculating, so although we haven't been told what the units are, we can still say it's in some kind of cubic units. And we should always do this for volumes of revolution when we don't know the type of units we're working in. And that concludes the question.